said he uses motivation.
I will be.
Yeah,
Okay.
Well, I said.
Let me define real quick. Now, notice what I called this section heading. It's confidence intervals, and our book calls it a large sample.
You can't even read what that says.
Large.
That says lead.
Oh, I had to add the R. I forgot. I had to add the R. I forgot. Okay. So, our book considers a large sample anything of 30 or higher. So if I survey 30 people or more, we consider that a large sample. Now, this is kind of a random number. I've seen some textbooks that 50 is what they consider a large sample. So every book could be a little bit different, okay? For us, 30 is the magic number. 30 or more, we're going to consider that a large sample. Or, what symbol is this? What's it mean? What's it mean though? Of, Cody, just put your phone away. Of a sample or a population. This is a population. So, when do you go to section 6.1 of your notes? If n is greater than or equal to 30, or you're given a population standard deviation. Okay, so what that means now is I could survey 20 people, but as long as I give you the population standard deviation, you would still do this. Okay, if I give you 30 people, or let's say 40 people, and I give you the sample standard deviation, then I would follow this section because it's greater than 30. Okay, so do you see you have to kind of reason out what method you're going to go to. So what do you think section 2 is going to be when n is less than 30? Okay, and so that's where you have to kind of base things off. All right, but here is the whole purpose of this chapter. The whole purpose is okay. The whole idea of this chapter is you are going to use a sample to make a prediction about the entire population. Okay, back to the University of Idaho. I would much rather survey 20 people, 30 people, 40 people than 16,000 people to predict the age of the university. And I can be within 99%, 95%, 90%. And you think about it, this is about how all surveys are done. All surveys are done this way. Nobody surveys the entire population. Okay, they always do a sample because it's easier to do. Okay, and we can be very accurate with it. And I want you to kind of start noticing when you start to see surveys, you'll notice that at the bottom of the survey they'll say within 4 plus minus 4%. That means they're like 96% confident. They're within 4% of what they think the actual outcome is. Okay, so they're making predictions. Okay, the first thing we need to talk about is this. Go to your Z chart. Okay, notice at the very bottom on the negative side, it gives you your critical values. It gives you your critical values. Okay, so notice that this gives you what 80% level of confidence is, 90%, 95, and 99. These are the main ones. If I gave you 12 questions on your test, probably 10 of them are going to be one of these. You know, there's going to be a couple that I want you to do an oddball one, okay? But these are the main ones, all right? We need to show you how to find these, okay? They're not quite as easy as you think. I know that our Z chart in the past, we just read it, but we really don't use this area very much in here, and we'll talk about when we do. All right, so let's show you how to find. Now, here's a hint. Whenever we do find an oddball, write it down. Then you never have to look it up again, okay? So if I show you how to find 84%, then add it, Okay, and then that way you have it and you don't have to calculate it. So I would say by the time that we're all said and done with this chapter, we'll probably have about 10 of these filled out. And chances are it's going to be one of those on your test. Okay, so always write them down once we find them. All right, so here's how we do it. Let's show you how to find a confidence interval. We're going to do one that they already given you. If you look at point 8, let's show you, they tell you that the answer is 1.28. Let me explain how they found it, and then we'll do a couple oddball ones. Okay, here's what it means. When you tell me that you're 80% confident, point 8, you are telling me that you're confident, you are 80% confident that the population mean is going to fall between these two values in the shaded regions. Okay? If this represents 80%, point 8, how much of the graph is not shaded? 20%, right? This represents 10% and this represents 10%, right? So you have a 20% error out there. Our Z-chart only tells you what side of the bar graph or what side of the bell curve. What does our Z-charts only tell us? To the left, right? We're going to look up this value, okay? So go inside your chart, and you're going to look up 0.10000.
539.
What did you say, honey?
You said 0.100.
Oh, well, it's 10%, sorry. So I should be using decimals. Let's
Yeah.
do this, sorry. So do we agree that this is 0.1? Okay, and then this would be 0.1?
Would they both be positive? Oh, I guess, yeah, I guess I can. Wait, on these.
Just a minute.
45.
What are we getting?
Wait, 5398.
0.1.
Wait, on the negative or positive side?
You're looking inside the chart, not on the sides.
Oh.
So you're going to want to look up 0.1000. Find me the closest value to 0.1000.
Oh.
And what is it?
Why are you gonna give us this one?
Wait, what is it?
5398?
100.
No. Like this, like
Yes.
in here.
If you look inside the Z chart, the closest value that 1,000 is to
Negative 1.3.
is 1003. Okay, that's the closest value to 1,000. Very seldom would you get an answer spot on. Okay, it's always going to have to pick the closest one. So what is the Z-score that matches this now? Negative 1.28. So our Z-score is always positive. I'm going to give you the formula. We're just kind of working it out. But there you go. This is what our confidence interval at 80% would be. It's called your critical value for Z. And if you notice on your chart, it calls it Z sub C. That means it's the critical value for Z. Here's the formula. All we do is we take our percent, whatever we give you, you take 1 minus that percent. You take the absolute value of it, or then you take it times a half, sorry, and then you take the absolute value of it. So all you do is I just take 1 minus 0.8, which is 0.2, I divide it by 2, which is 0.1, and I look it up on my chart. I just always want our critical value to be positive. So that's why we got to put the absolute value on the outside. Let's do another one now that you kind of get it. Let's do another one that we know. Let's do 0.95. Let's do 0.95. We already know the answer is 1.96, but here's how I would come about it. if I want to know 0.95, I'm going to take 1 minus 0.95, which is what? 0.05. Then what am I going to do to it? Times it by a half or divide by 2. Okay, times by a half, divide by 2. Okay, what's 0.05 divided by 2?
0.025.
0.025. Is it 0.00? Yeah. Now you go look that up. Go look up 0.0025.
Negative 2.7.
Oh wait, do I got an extra 0 in there?
Yeah.
Sorry. 0.025. So if I look up 0.025, notice it shows up exactly. 0.0250.
Negative
Which one's the
1.96.
Is it the 1.28?
Yes. Okay, we got it? So all I do is I take my percent, I subtract it from 1, which is 0.05, I divide it by 2, which is 0.025, 0250. I look it up. It's exactly in the chart at negative 1.96, and I take the absolute value of it. This is the critical value for 0.95. This is the value that we will plug into our formula when we have to do it. Okay? Let's do one more just so that, let's talk about 0.9. Even though it's on your chart, do you know it gives you 3 decimals? So we got to talk about why that happens. So, and then we'll do an oddball one. Here, let's do 0.90. So what's the very first thing I should do?
1 minus
1 minus it, which is what?
0.10
0.10. Divide by 2,
by 2.
which is point.
0.
So that's that, 0.0500. Now go look up 0.0500. Look up 500. I think of it as 500. Look up 0.0500.
Negative 1.6.
Okay. Do you notice that it falls exactly in the middle of 2? It falls between 0.0505 and it falls between 0.495. It is exactly in the middle of 2. When we did this one up here, it was closer to 1003 than the other one. So if it falls exactly in the middle, which this does, what you do is, what is the z-score for what is the z-score for 0.0505?
Negative 1.64.
Okay. What is the z-score for 0.0495? You're going to add these together and divide by 2. You're just going to average it. So I'll add these together, I'll divide it by 2, and I get negative 1.645. There you go. So when it falls exactly in the middle, and it doesn't happen very often, but when it does, you got to write down. What most people do is they average these together. Don't do that. Write down the z-score, add them up, divide by 2, and again, we always finish with absolute value. Our answers are always positive. Okay? Do we see our process? Those are all given for us. Let's finish up with an oddball one. I would write it at the very bottom of your chart. Keep adding on to these as we're going. Okay? All right, here we go. Let's find 0.92. Let's just say I want you to be able to do this, and I want you to be 92% confident. Kind of like, that's a weird number, but we can do it. So, to find 0.92, I would just go 1 minus 0.92, which is 0.08. I immediately divide it by 2, which is 0.0400, and I look that up. Take a minute. Look up 0400.
Negative 1.75.
I kind of agree. Okay, do you notice that for 0400, your choices are 0401 or 0.0392? Which one is it definitely closer to? 0401, which gives you a z-score of?
Negative 1.75.
Okay, negative 1.75. I immediately take the absolute value of it. There you go. I would write that down on your chart. A 92% confidence interval gives you a critical value of 1.75. Now, it seems like we spend more time doing this, and you might only have to do it once or twice, okay? But we have to be able to do it if it shows up. Are we okay? We all understand? Okay. We all good? All right. Next order of business, and we'll just kind of adjust it. You know, I thought we would be able to get through all the word problems, all that. We're definitely not going to. So maybe I'll have you get your brown box written down. Maybe have you do a couple problems, and that's it. Okay. So, do you want me to just shoot it up on the overhead?
Yes, please.
Is it easier for you? Okay. You're going to need to take a minute here and write this chart down. Here are some things that you can shorten on it. Shorten it up so you don't have to write as much. I'll try to fix my screen here.
Red, orange, green, blue.
Oops, does that do that? That might be do. Oh, there we go. Good job. Okay. Here's what I would write down. I would definitely write down step 1 because this is the criteria that makes you do the following steps. So, number 1, if sigma is known, maybe you don't want to use a symbol. If population standard deviation is known, you follow this chart. So when you're reading your word problem out and it says the population standard deviation is, then you're doing this chart. Okay? The sample is random. We randomly select 20 people. And either the population is normally distributed or n is greater than or equal to 30. Okay? So let's just say that they say the following standard deviation is. They don't tell you what it is, but they survey 40 people. You follow this chart then. Okay? So you got to make sure you get that down. Step 2. If you're not given X bar, if you're not given the sample mean, then you have to find it. And you'll do that on your calculator. Okay? So if I just give you a bunch of data, then do it on your calculator. So maybe for step 2, you just say use calculator to find X bar, if not known. 9 out of 10 times it's given to you. Okay, so the X bar will be given. Step 3 is your Z chart. That is this little column right here. Your critical value for Z, your Z sub C, that little table at the very bottom. That's what we need. So use table 4 in appendix B. It's called the critical value of Z sub C, Z sub C. Step 4, you're going to find the margin of error E. It's just E. Look, the formula's not bad. Look at the formula. Pretty darn simple. It's Z sub C, so it's either like 1.96, 1.75, whatever our Z sub C value is, times the population standard deviation, divided by the square root of n.
Is there a way that we can plug this into our calculators?
Like that formula? Well, yeah.
Or
So you would go like 1.96 times 3.5 divided by the square root of 50. There you go. That's your margin of error.
Or is it like a format of like the Z sub C?
That, no. You're gonna have to find that off your chart. But like I said, it's almost always one of these listed. Okay? Now, when I do my very last step, this is your prediction. This is your confidence interval. It's your prediction. Like, I'm 90% confident that the average age of the University of Idaho is 22 to 24 years of age. I don't do these two at all. I like your final answer to be like this. So maybe all you need to write down, notice how you showed me your final answer. It's X bar minus the error, less than or equal to mu, X bar plus the error. So in other words, you're giving me, I don't know why it's freaking out, but
7 seizures.
you are predicting where the population is going to fall. And that's why we put mu in the middle. Mu means population mean. X bar is your sample mean. So we're making predictions off of our sample. So again, you use this chart when your sample's greater than or equal to 30, or the population standard deviation is given. Maybe your homework today is you'll write down this example, and that's it.
Yes, please.
But I will grade your notebook tomorrow. It counts as one of your assignments. Just writing this chart down in the word problem.
Do we have to write down the in symbols part too?
Well, that's the part that I would. That's, to me, what I feel is the most important, because they give you the formulas and everything. Like, I would write step 1 down in words, but 2, 3, 4, and 5, I don't know if I'd write all that down. I would just make sure that I understand that E is your error, 3 is your Z chart, table 4 is our Z chart.
Can we just write use Z chart and say use table 4 and index
Yep,
B?
use Z chart. You could even say bottom left, Z chart. It's your critical values. And then again, you don't need to write left endpoint, right endpoint. We never do that. We just show our final answer as an inequality statement.
What? So why are you writing that down?
What?
The left endpoint, right?
You don't, they're just showing you to get this answer, you take X bar minus error. We just do it all at one time. So you just want this one, really.
Only the interval one?
Yeah.
And then we just write the bottom area of Z chart
For step 3?
for the use tables.
Yeah, you just say you want the critical values. Okay, so while you're kind of finishing that up, let me just show you how the book does their work here. I'll just raise it up just a teeny bit.
So we should write that again.
No, I don't want this part down. Okay, but see how they're doing this? So what they're doing is to get your final answer, and I don't know what this data represents. It looks like grocery store employees. But they're predicting that, the mean number of hours worked. This represents mean number of hours worked. They're predicting that all grocery store owners, and they're 95% confident, work between 27.2 hours and 32.0 hours. That's what they're predicting, okay? So this is why I like your final answers to look like this. So that's why I'm only having you writing this down, okay? So all we do is we just take X bar minus the error, X bar plus the error. Very simple. Just subtract the error and add the error, okay? So you're predicting that everybody works this many hours. You're 95% confident that all employees work between these hours. Not full-time, full-time.
Is that the one we're writing down?
No. I just wanted you to see it. How many hours till you're full-time? Well, let me replay. How many hours before you get benefits?
I'm gonna go with 25.
30.
Oh,
30 hours is when they have to give you benefits. Okay. Here is your final thing. We will do this tomorrow, okay? But this is the problem we'll work out, okay? You don't do the solution or anything like that, okay? So what we're going to do, we're going to predict tomorrow, and I just like to say University of Idaho, we're going to predict we're going to be 90% confident that what the mean age of the University of Idaho is. And notice that we're going to use their data. So let me just kind of read it. A college admissions director wishes to estimate the mean age of all students currently enrolled in a random sample of 20. So at this point, would you say that you would use this chart?
Yes.
Why?
This is random?
But did we survey 30 or more?
No.
No. So at this point, you're like, oh, wait a minute, this could be section 6.2 of my notes. But as I read on, it says the mean age is found to be 22.9 years. From past studies, the standard deviation is to be known to be 1.5 years, and the population is normally distributed. So right there, that is them telling you that you are given the population standard deviation. Because it's based off of a population and it's a normal bell curve. That's what normal distribution means. And so since it's telling you the population is normally distributed, then that standard deviation is the population standard deviation. So therefore, we would follow our chart. Okay? When we do it tomorrow, we'll do 90 and 99%. We'll like show you both of them so you can see the difference between them. But anyway, write that down. I'll just check it off tomorrow. Okay? We'll count this as your first assignment.
Are we gonna do that 5% on our next test?
No.
What?
You didn't hear me?
She was taking the test.
We're not doing 5% this time. We're going to do it by, if all your work is turned in and completed, you get to use your notebook on the test.
Oh.
Or you get to use nothing. You're going to have to use your memory for all of this.
Oh my God.
So you'll have to memorize all the formulas and everything on your own. Not a good idea. Okay, that's it. I'll leave that up. Hopefully you get it all written down today. What's up?
I'm not gonna sit anymore.
Kyle in trouble?
No, Cody, your car door's wide open. Yeah. And the lady that just reported didn't close it because she thought maybe you left your keys in there or something, so.
Who's breaking into your car?
So, yeah, as soon as you get a break, you need to go close your door.
Okay, sounds good. Thank you.
It's probably dead now. You're gonna have to give him a jump. This dome light's been on.
Oh, you break into your car.
Someone
to get more out there today?
Wait, are you still in senior assessment? Because they what if they crawled in your car? And left the door open, that is not. Well, that would get him to go outside. I don't want to.
I know.